Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, I'll be talking about logistic regression. So, in our previous videos, I've talked about the simple regression like linear, polynomial, multiple, right? And then we have started with the topic called classification. From this video onwards, we'll be talking about the types of classification algorithms. So, we're going to talk about the first one. It's called logistic regression. Let's get started. So, the logistic regression is used to predict a categorical dependent variable from number of independent variables. So, the key difference to the linear regression here is that we are not predicting a continuous variable, we are predicting a categorical variable. For example, here we have taken one example. For example, you might be working for an insurance company and you want to predict will somebody purchase a health insurance that your company is offering, yes or no, and it's very simple, yes or no. It's a categorical variable. And you might want to predict this dependent variable based upon independent variables such as age. That's why we have this equation available, tilde. If you remember from the R background, if you remember from the implementation in R, we used to have dependent variable, then we tilde sign, then we have the independent variable. So in this case, independent variable is age. So depending upon the age, will they purchase the health insurance that your company is offering? Let's explore this. In this case, we have a graph available. On the x-axis, we are having what? We have a age, okay? And on the y-axis, we have what? The binary outcomes, yes or no. The age is between the 18 years to the 60 years of age. And y-axis has a simple binary outcomes, yes and no. And there is no in between. It's either yes or no, means 1 or 0. Okay. So in this case, we have added the horizontal line for the illustrative purpose. So what will our data set look like? So let's say we got certain number of observation in a data set, and we know that people's age, and we know when they were exposed to the offer, whether they will purchase the insurance or didn't. So you can see in this case, these are the no, meaning is those guys haven't purchased our health insurance, okay? And this one, they have purchased our health insurance, yes or no. So you can see now this graph, if you just ignore this curve, I'll be talking about this curve in a while. If you just see this two lines here, we have a horizontal line available, and you can see this is not the one that we used to work with the linear regression tutorials, right? This plot looks very different to what we were working in the earlier tutorials. So in this case, we can't simply draw the simple linear regression line, a sloped line through these points, okay? So now, if we can talk about the equation on the left, you can see here, on the left side we got the algorithm, on the right side we got the same part that we used to have in a simple regression, right? On the right we got the same part. So important value to us here is the p. So what is p? That's a probability, right? That will be working with just now. We'll see it in action. So let's now this is the curve I was now going to talk about. This is called as a logistic regression curve. This is how it look like. It's also called as a sigmoid curve, okay? So let's suppose we have two new observations available. You can see 35, 45. Let's suppose we have two guys of age between one guy has a age 35 and somebody of a age 45. So what we will do, we need to project these values to this curve, okay, and find out where they fit there. And logistic regression will give us probability. So this value, everything here is 0 or 1, right? We all know. So we can have two binary values, 0 or 1, and in between there are probabilities. This section is all about the probabilities. So logistic regression will give us probabilities of somebody saying yes and somebody taking up that offer. For example, in this case we have written the chance. So for 35 years old, there is a 42% chance that they will take up the offer based upon this model, right? So what this model is predicting? It's predicting that there is a 42% chance that they will take up an offer, and for the 45-year-old, there is a 81% chance that they will take up an offer. So we could stop here. This is the p. This is the probability that we see in the equation, right? So on the left side, that's hidden in the algorithm. So we could stop here and we can use these probabilities, and in some use cases, that's what logistic regression is used for. We just deal with the probabilities once we have them. But in most of the cases, we want a binary outcome, yes or no outcome. And for those situations, we need to split this curve into two. You can see here, we can see one dotted line here. We have split this into two parts. Anything above this line is this middle line, above this probability of 50% or higher will be projected into yes or in a binary 1, and anything below this 50% line will be projected into no, means a binary 0. So our points would end up here. So based upon this logistic regression, we would make the conclusion that 35-year-old would not purchase our insurance plan, but 45% old would purchase our insurance plan. And just like with the linear regression, you can have a multiple independent variables as well, like this. In this, you can see in this picture, we can have a multiple independent variables. For instance, we have age, income, we have this level of education, we have a family or single. So this equation will look like this. Okay, so because of the increase in independent variables, you can see this equation has been changed as well. I hope you must have understood from this short little video what is the meaning of logistic regression. In the next video, I'm going to show you how we can implement the same in our programming language. Thanks for watching, guys. See you in the next video.